adding and subtracting radicals. Remember, radical is what you've always been used to calling a square root. So we're going to be adding and subtracting square roots. So if we look, if I have 3 square root of 5, notice that's not the index, so that's not the number in front of the radical. So this is actually a square root, so it's 3 square root of 5, not the third root of 5. So make sure you put that in the correct spot. Then we have 2 square root of 5. So if you look at this problem, you will see that there's a 3 and a 2. Just like when we were doing simplifying radicals and we ended up with numbers out here, those are coefficients, just like whenever we're talking about 3x and 2x. So if I were to add 3x and 2x, we get 3 plus 2 is 5. Remember, this is a plus sign between them, so I need to remember to add those. I do not write it as x squared. This is where, when we're switching back to simplifying by adding and subtracting, students get mixed up. You don't want to say it is x squared, because it's x squared when I say x times x. That's when you get a squared. This would just be 3x plus 2x. 3 plus 2 is 5. So we're not actually multiplying anything, so we're not going to change the exponent. That's where students start getting mixed up when we go back to adding and subtracting. Since these are both x's, I can combine them. If it would have been a 3y plus a 2x, I couldn't combine them, and that would be as simplified as it could get. It's the same idea when you're talking about radicals. So if they were not both a square root of 5, you would either need to simplify first and then see if you could combine, or they would just not combine. But since they're both a square root of 5, you can combine. So 3 square root of 5 plus 2 square root of 5 is the same thing as this. It would be 5 square root of 5. And that would be my answer. Okay, it's the same idea when you are subtracting. So if I had 10 fourth root, notice the 4 is the index on this one, 8 minus 3 fourth root of 8. So all this is doing is kind of like an exponent. So if we had 3x squared plus 5x squared, you still just add those numbers. It's just a different type of x. So this is just a different type of radical. So you're still just going to look at this number right out in front. So 10 minus 3 is 7. The 4 stays the same because it's identifying the type of radical we had. And then the 8 stays the same as well, because it's just the number underneath the radical. So if I have 10 fourth root of 8 minus 3 fourth root of 8, your answer is 7 fourth root of 8. Okay, the next problem, if I have 3, or the third root of 40, plus the third root or cube root of 5. So let me separate those examples so that you know I'm starting a new problem. So I have the third root of 40 plus the third root of 5. Notice neither one of these have, or these two problems do not have the same information underneath the cube root. So in order to be able to combine these, I'm going to have to get them to have the same information underneath the cube root. So just like we've been doing simplifying radicals, I'm going to go over and do the factor tree. So I'm going to do the factor tree for 40. And you can pick any numbers. This is something that people have been questioning. Well, if it's a 40, do I have to do 4 and 10? Could I do 2 and 20? It doesn't matter, because in the end, all of the numbers that you have, all of the factors you have, should still multiply out to get 40. So if you're unsure if you're correct or not, you could just multiply out all of your factors and see if you get 40. So I'm going to do 2 and 20 just because that one's the easiest for me. Some people 4 and 10 might be the easiest. Actually, I am going to do 4 and 10. I'm going to go over here and do it, just because somebody said that my example the other day didn't have something that simplified here. So 4 can break down into 2 and 2. 10 can break down into 2 and 5. And none of those can simplify anymore. This one is 2 and 10, and then 2 and 5. Notice there are 3 2's and a 5, 3 2's and a 5. So it's still the same information, so it doesn't matter which way you do it. So again, it's third root, so I'm looking for 3 2's, or a number times itself 3 times. So I could rewrite this information as the cube root of 2 cubed times the cube root of 5. Remember, we separate them out, and then 3, or the third root and that cube, cancel, so it would actually be 2 times the cube root of 5. So this information right here simplified to get this information. So it was 2. Remember, we don't have to write the multiplication sign. I could just write cube root of 5, and then plus the cube root of 5. Just like when we're talking about variables up here, if there is no number out front, it's just like saying it's 1 times that information. So I need to remember that it's 2 plus 1, because if there is no number, there's an implied 1 or invisible 1, or however you prefer to say it. So I would do 2 plus 1, which is 3. So it would be 3 cube root of 5. So again, if you look at this problem, we simplified this by writing the cube root of 5, or 2 cube roots of 5, I'm sorry, and then we did the third root of 5. All right, sorry, technical difficulties. So this is our next example. It is similar to this one. I'm not sure where the video actually cut off at. So it's similar to this one, where you're going to have to simplify because they don't both have the same radical. But this one, if you look, the 3 square roots of 5 did not actually simplify because the 5 doesn't have any factors or anything that multiplies into it 3 times itself. So that one is as simplified as it can get. And then if you look at these, we're going to see that both of them can simplify. 44, some people can easily look at that and say, oh, I bet there's an 11 in that. And then you can also look at the 99 and say, oh, I bet there's an 11. But not everyone's that great. So again, we're going to do our factor tree of the numbers. So factor tree of 44, which could be 4 and 11 if you go and actually divide it. So if I had my calculator, I could take 44 and divide by, let me clear that, 44 divided by 2 is 22. So you could also do 2 and 22. I did 4 and 11 just because that's the one that I easily saw first. And then 4 breaks down into 2 and 2. So then we could rewrite 44 as 2 times 2 times 11. 2 times 2 can be written as 2 squared times 11. And then it's the square root. So square root and square root. The square root and the squared cancel, so it would be written as 2 square root of 11. That was for that one. So we would actually have this information simplified to be 2 square root, oh, my pen stopped working for a second, of 11. Well, we already had a negative 3, so it's a negative 3 times the square root of 44. So I'm going to do negative 3 times 2. So negative 3 times 2 is negative 6 square root of 11. So since there was already a number out front, just like these ones up here that already had a number out front, I just need to remember that it's that times this information. So then I needed to do negative 3 times 2, which is negative 6. Okay, now let's go over here and simplify 99. So we have 99, which can simplify to, again, I said 11's the easiest. So you could do 99 divided by 11, which is 9 and 11. 9 can break down or can be factored as 3 and 3. So I could write my factors as 3 times 11, or 3 squared times 11. Place both of them under their own square root. Then we have that and that cancel. The 11 doesn't cancel with anything, so it would be 3 square root of 11. Rewrite the square root of 99 as the 3 square root of 11. I'm going to bring it down one more time just because there was an extra step here. This one doesn't have an extra step because there was no number out multiplying. Then we have negative 6 square root of 11 plus 3 square root of 11. Notice again, that's not the index. That is just the number multiplying out front. So I could put a multiplication if I wanted to, but I don't have to. Okay, and then negative 6 plus 3, if you aren't sure, negative 6 plus 3, or if I owe you $6 but I only give you 3, I still owe you $3. So negative 3 square root of 11. That is adding and subtracting radicals.